Hello guys, so today we will talk about the algorithms which is used to distribute traffic from client to load balancer and how load balancer is actually distributing traffic in between these three servers. Okay, so what are the algorithms on a high level, what are the algorithms getting used to distribute this traffic? So we will understand this one. So the first algorithm is round robin. So round robin is what? So whenever a request is coming, so what will happen? It is a counterclockwise. Okay. So what load balancer will do? Load balancer will send the first request to S1. Okay. So when the first request comes, it will send to S1. So when the second request comes, it will send to S2. When the third request comes, it will send to S3. When the fourth request comes, it will send to again S1. So this way, whenever request is coming, it will just send one by one. First will be S1, then will be S2, then will be S3. Okay. So this way, it will, on a counter, it will send one by one. Okay. It will not check whether this S1 is heavily loaded or something, or this S1 is, serving more request at that time than S2 or not. Okay. Just it will send on a particular counter basis, one by one it will send. This is called the round robin one. I hope you understand, right? So for the first request, when it will come, it will send to S1, consecutively send to S2, then S3, again S1, S2, S3, then again S1, S2, S3. This way it will keep on running. This is called round robin. Okay. And when it comes to weighted round robin, so what does mean? Weighted round robin come into picture when, just consider this S2 is a big machines, okay, and this S1 is a small machines, okay, and this S3 is also bigger than S2, okay. Suppose this has 2 core, these are 2 core machine, this is the 4 core machine, this is the 8 core machine, okay. Then the weight of S1, if it takes 1, right, the weight of S1 is, if it is 1, then S2 will be 2, right, and S3 will be 4, right. So what that means, what that weight means at a instance, if S1 can handle 1 request, right, S2 can handle 2 requests and S3 can handle 4 requests compared to S1, right. So in weighted round robin, this weight of server gets considered on distributing load. Okay. So what will happen then? So when the first request will come, it will come to S1, right. So the first request will come to S1, second request will come to S2, third request will come to not S3, it is S2, because it will check, I sent one request to S1, then S2 will be able to handle 2 requests, right, because S2's configurations, S2's weight is more than S1, okay. So fourth request will go to S3, okay, consecutively fifth will be go to S3, sixth will go to S3, seventh will go to again S3, then from 8th request it will go to again S1. So that means the weight of that particular server gets considered when distributing the load, okay, in this particular algorithm, that is weighted round robin. Okay, I hope you understand. This is weighted round robin. So the next one is least connection. Okay, what do we mean by least connection? Least connection means whenever a request is getting sent to the server, right, one connection is getting built up, so that means, suppose at a instance S1 is handling 5 requests, that means 5 connection, S2 is handling 3 requests and S3 is handling 7 requests, right. Then what in this, if you use in this this particular algorithm, then the request will travel to the particular server which is handling least connections. So this is S2. So then the request will come to S2. So S2 will be handling then 4 requests, right. So what will happen? The next request will come, you know, to S2 again. If S1 is still serving that one, So the whole idea is the request will only travel to that particular server which is currently, you know, which is currently serving the minimum request. That means the least connections is getting served on that particular server. Okay. So the next particular algorithm is least response time. So what that means? Least response time means, so load balancer is checking if S1 is serving a request in 60 millisecond and S2 is serving a request in 80 millisecond and S3 is taking 120 millisecond. Okay. So S1 is somehow is getting much faster than S2 than S3, right? Then what load balancer will do? If you use this algorithm to distribute the load balancer will check which server is sending the response very fast, right? So it is S1. So load balancer what will do? It will distribute the traffic at that time to S1. So how it happens, right? How S2 is taking more, S3 is taking more than S1. If it is same configurations machines, it may happen sometimes. Suppose garbage collection is happening. Okay, in the code garbage collection is happening. So your server is, you know, busy with collecting the garbage, right? So that time your request processing will get slow, right? So that time your response time will get increased. So in those cases also, you know, whenever if you use this least response time, then your load balancer will always distribute the traffic to that particular server which is sending the request in the minimum time. So here, if for an example, if we take S1, right, so it is sending the request to S1. Okay. So all this what we have discussed till here, right, is able to survive when we have stateless request. So if you ask me what is the difference between stateless and stateful request? So stateless request is the one where server no need to store any context or any data, right, of the previous request. Okay. So each request can be served independently without having any data or any context stored of the previous request. That is called stateless request, because all these algorithms are not storing any particular data, right, any particular data to the server. Okay. We are considering there is no data maintained in the server. So why? Because just think, if any session gets stored in S1, the next request may come to S2, right? Next user request of the same user may come to the S2 in this algorithm. So then what will happen? In S2, that particular user will not get the session context details which we stored in the previous request in S1, right? So eventually the request will get failed. So if it is stateless request, you can use in, you know, among these 4 algorithm, you can use any of them. Okay. So what will happen if we have stateful request? So what do we mean by stateful request? Stateful request means server have to store some of the context or some data of the previous request to process the next request, right? So that request is called stateful request. That request is called stateful request, right? So for stateful request, you have to use either IP hash or source hash or consistent hashing. Okay. So IP hash or source hash or consistent hashing. So these two is for stateful request. These two is for stateful request. Okay. Anyway, we will talk about these two algorithms in detail in the next lecture, but I will just go through on a high level what this IP hash or source hash exactly all about. Okay. So what this algorithm is, right? So by name you can understand we are using some hashing. Right? So how load balancer is deciding which server to send the details, right? So if it is a stateful request, stateful request, then our primary goal has to be that each user request we will try to send to the same server, right? Suppose user 1 is logging in and he is sending a request, the load balancer is sending the request to S1. That means whenever this user 1 will log in, it will try to send the request to S1. Whenever the user 2 will log in, if the user 2 request is going to S2, then always whenever the user 2 is logging in and sending some request to the load balancer will try to send this request for user 2 always to S2, not to S1, right? So this way, if we are storing any local data, if we are storing any session data in any of these servers, so that the user's request can be served from taking context of the previous request from the same server, because sessions are not global, sessions are only local to each server, right? So this is the whole idea of these two particular algorithm, that it will try to maximize this possibility of sending one user request to the same server. Okay, this is the whole idea, right? So what happens in IP hashing, what it does, right? It uses one hash function, right? It will use a hash function of a key, okay, of a key. It will use, suppose user ID or any key they will decide, right? And it will do a mod of number of servers. So here number of servers is 3, right? So if this mod will come 2, then it will send the request will 2. So what will happen here, right? If the cluster size is fixed, right, then what will happen? It will always, this particular key's hash function, as the hash function will always be same. So the hash on mod of number of servers will always come to, that means the load balancer will always decide to send this data to S2. You got my point, right? So the functionality of IP hashing is this one, hash function of any key, mod of number of servers, then it will come a number, and that number will be the server index number, and this particular, based on this number, the load balancer will redirect the request to that particular server. Okay. So as the hash function will always be same and the number of cluster or the number of node will always be same, that means it will always go to the same server. Okay. This is the whole idea of IP hashing. Okay. So, but there is a challenges. What is the challenges? If the cluster size is not fixed, if it needs to be scaled, right? So if we utilize automatic scaling, if we utilize auto scaling and our load balancer is adding, right, our infrastructure is adding another server node dynamically and attaching to this particular load balancer, then what will happen? So same hash functions you will use, right? But you will now, mod of number of servers was earlier 3, but now is getting changed to 4, right? So then the value earlier was coming 2, it may come 3 now. So that means the local data you stored in S2, but now the request is not going to S2 as the number of server got increased, right? So now it is going to S3. So what is happening? You are losing all your session data, you are losing all your local data whenever the number of server is getting changed, right? So another case, right, if it doesn't get increased, any server got crashed, suppose S2 got crashed, right? So then the number of servers again becoming 2 from 3, same case, right? The hash functions of the key and mod of number of servers will be 2, definitely the result will be differ, right? And the session data or the local data we will lose, and the request will now go to the another servers and the purpose will not get fulfilled. So, and another thing is all your data, not all your user, not 1, 2, all your user in this particular IP hashing is getting good, is going to be moved to different server. So what is the problem? All your user is going to be moved, right? Is going to be moved to different server. So that means the impact is huge. All your servers, suppose you have 1 million servers, suppose you have 100 user. Now 100 user is going to be losing all the previous context data, all the session storage data, all the caching data, everything they are losing, right? So now what is going to happen? Load to your server is going to be heavily increased, right, heavily increased whenever any change is happening, right, in this IP hashing. We will talk about these two things in the next lecture in a very detailed manner, right. I just want to give a highlight to you what exactly we are going to study in the next lecture. So, next is consistent hashing. So, what is consistent hashing? The problem you understood, right. So, problem is any particular change in the number of servers is going to impact all the users, not even single user will miss, right, all the users going to be impacted. Now, with consistent hashing, that is going to be reduced, Now, 100 users is not going to be affected. We will try to minimize it, from 100 maybe 5 users will get impacted if we use consistent hashing instead of IP hashing in case of any change in the number of servers. Okay, I hope you got my point. So, what is going to happen in the consistent hashing? The main idea is we will try to minimize the impact that we had in IP hashing. Okay, in IP hashing, all our users was going to get moved to different servers whenever there is any change in the number of servers, in the cluster, right. Now, with consistent hashing, the impact will not be global, the impact will not be for all the users, it will be limited to certain users through this particular algorithm. So, what is this algorithm? On a very high level I am telling. Okay. So, earlier we were doing hash of key, earlier we were telling hash of key, mod of number of servers, and we are getting a number and we are assigning a server, right, in IP hashing. Now, in consistent hashing, this mechanism is going to get changed. Okay. So, what is going to happen? So, every server, every load balancer server, suppose Nginx or everything is going to support 32-bit or 64-bit hashing. So, what that means? In 32-bit hashing, if you hash any particular data, you will get a value from 0 to 2 to the power 32 in between. Okay. So, what is happening? If you hash any particular key or any data through any hash functions in any server which is supporting 32-bit hashing, then the value you will get from 0 to 2 to the power 32, and for 64-bit 2 to the power 64. So, whenever you do any particular hashing, the value will come from 0 to 2 to the power 64 for 64-bit machines and 2 to the power 32 for 32-bit machines. I hope you got it. Now, in consistent hashing, we were making a circular hashing. So, what that means? What was happening? It was coming from 0, that is what I am telling. I am considering 32-bit machine. Okay. From 0, it was coming, if you take an array, right, then the array first index will be 0 and the end index will be 2 to the power 32, right. So, now we were just joining a line here, So, what is happening? From 0, it will start going from here to 2 to the power 32. So, after 2 to the power 32, it will come to again 0. You got my point? It will come to the again 0, right. So, now we have 4 servers, server 1, server 2, server 3 and server 4. So, what we have to do now? We have to hash each server. Okay. We have to hash each server. Okay. So, suppose we hash the server 1 and we got a number, and the number is coming, suppose 182, just considering, right, and this 182 is coming here. So, S1 is relying here, got my point, and the hash of S2, I am considering this 500 and I am considering 500 is here. So, S2 is here. Hash of 3, I am considering it is coming 1200 and I am considering 1200 is here. So, S3 will be here. I am considering hash of S4, it's suppose 5000. Okay. So, that means suppose 5000 is here. So, S4 is going to be here. So, what we did? So, what we did? we did hashing of our servers and we placed our server in this ring, right. So, in this ring, so that means we did hashing for our servers. Server 1 is value, suppose hash value is coming 182, it is coming 500, just assumptions, it is coming S3 is 1200, it is coming S4 5000, right. So now we are getting consistent hashing circular map where we have placed our all servers based on the hashing functions. Okay. Now one request comes, right. So for each request we will get a key. Okay. So this key is going to be customized key. We can have our own key. Suppose we are taking URL, user ID or something. Okay. And we are maintaining a key. So that key we are going to hash that particular key. Okay. So if we hash that particular key, we will get a value in between same 0 to 2000, 2 to the power 32. So suppose we got the value is 300 for that particular user. So that means the user is relying here in between 182 to 500, right. Now this user comes here. So now which server is going to handle the load? So based on this algorithm, the server which is going to be handled, right, clockwise the next server which is available. So clockwise which server is available? S2. So that means for this user, S2 is going to handle this particular request with consistent hashing. Got my point, right? If you are not understanding consistent hashing fully, don't worry, we are going to have detailed lecture on the next lecture related to this IP hashing and consistent hashing. On a high level, just understand this is how this circular, we make a circular placement of our servers, and based on this hash functions data, we actually assign the server. Okay. So now how it is reducing the impact then? Okay. Suppose we have added another server S5, right? We have added another server S5. Okay, before we added another server S5, suppose another user request come and we have has the key of the user request and we found a value that is 6000, right? So that means it was relying here based on our algorithm, the server which is going to handle that particular request is going to S1, right? So for 6000 earlier S1 was going to handle, right? Now base for our scaling, we added another server that is S5. We added another server that is S5. Now what we did, we has S5 and we got a value of 9000. We has S5 and we got a value of 9000. Now what is going to happen? 9000, suppose I am going to rely here and our S5 placement is here, right? Now our S5 placement is here. So now what is going to happen? Where is that impact, right? The impact now is only in this region, right? Why? Why? Because earlier from S4 to S1, all the request in this whole region was going to handle by S1. Now from here to here still S1 is going to handle, but from here to here S5 is going to handle, not the S1. So the replacement of servers for the users will be limited to only this portion, not global. Okay. But with IP hashing, what was happening? The replacement of servers was happening for all the servers. But with consistent hashing, it is limited to one portion, not all the users. Okay. I hope you got it. How consistent hashing exactly helping? If you are still not clear, just understand this way. Okay. Suppose another user came, right, whose hashing is coming 7000. Okay. So this is coming here. So what was happening? Suppose S5 was not there. This request was going to be handled by S1, right? But now after S5 replacement, this hashing is going to be done, this request is going to be done by S5. So what is happening? But after 9000, if something is coming 10,000, it is still going to be handled by S1, right? Not S5. So the impact will be predictable. So what will happen? The consistent hashing, the impact will be predictable, and the portions of users for whom the server is going to be changed is very limited, not the global. So this is the whole, on a high level, what are the algorithms which is getting used in the load balancer to distribute the traffic. Okay. In the next lecture, we will discuss in detail what is consistent hashing, and how it helps. Everything we will discuss. Okay. So in this lecture, at least we understood on a high level, what consistent hashing is, how it exactly helping to reduce the impact, if we have any change in the number of servers. Okay. This is it for now. Thank you so much.